Hey everyone, and welcome back to the channel. And I'm feeling a little bit inspired today based on some reading I was doing this morning on the latest threat report released by the DFIR report. It's kind of hot off the press here. You can see yet another black suit ransomware case here. And if you don't know what the DFIR report is, I've talked about them before, but they are a fantastic resource filled with a bunch of world-class analysts that are performing investigations into real threats and documenting them in some very well-structured reports with key takeaways. They map things to the MITRE attack framework and break down the different attack phases, and then provide us with a very nice set of indicators, right? So just an incredible resource here, and one that I often recommend to be almost some required reading for you. But anyways, there's a specific technique that I was reading through and was just like, what? Really cool stuff here. So again, we're not going to go through the whole report. I encourage you to read it on your own. And let me just figure out who wrote this report. So under analysts here, you can see this was written by Pigerlin or Pigerlin. I'm not sure how to pronounce your name. UC1 and Mixed Up. So all credit goes to them for some fantastic investigation here. So I'm just going to kind of jump through the initial access portion here. Basically, we have a fake Zoom installer that sort of led to this compromise. But specifically, I want to talk about the stage 2 of this payload because it's a technique that I'm not sure if I've seen before. I'm sure it's been documented. I'm sure it's been researched and maybe seen before in the wild. But it's something new to me that I thought was just brilliant, right? Sometimes you see these cases and you just identify, like who would have thought of that? And this is one of those cases, right? And so we've seen command and control servers or, maybe download cradles hosted through things like Discord, other social media sites. Have you ever seen one hosted through a Steam community public profile page? Specifically using the username of a Steam account for sort of this, to host this network indicator, right? The actual IP address to download the second stage payload from. Right. And if you look in the sort of previous, the name history here, right? This Steam user has also played as these other IP addresses here. You can see, so we see some history here, right? And it looks like we have this like I1IL sort of in between the IP address. I'm not sure what this is. If I were to take a guess, maybe it's to sort of bookend the IP address. So when it's doing some, regex or doing some sort of string matching to find the IP address or whatever indicator or artifact, it knows where to look maybe, but I'm not entirely sure. And so what I actually did was try to search for this string to see, again, if it was documented anywhere or if there's any other reference to this in the wild. And when I search for this, we get some weird AI result, maybe a reference number to some sort of weapon system diagnostics. All right, maybe. But again, I saw some things that maybe, I don't know. But as I kept scrolling down, I actually found an active sample of this perhaps malware variant, right? So this is a literal public Steam profile page. It's not the same one in the DFIR report example, right? We have a different IP address here. The actual, if we take a look at the actual URL of the Steam account, it's a little bit different. Actually, I need to zoom out to do that, but get my point here. This appears to be a different example, right? And we even have some different previous names here, right? So in this case, I don't know, maybe the attacker did a little typo there. I don't know what this is, maybe a port number, who knows, right? But the point is, this is the technique, and clearly it's something being actively used, right? And if we head back over to the DFIR report here, let me try to go back. We can read here, the malware then established a connection to a Steam community profile page to obtain the IP address hosting the second stage of the malware, right? And I'm not sure if it's still active. I assume it's not, but we don't really need to dig in that far. The point is, the idea here is that, it would execute this sort of download cradle or this dropper file that would then reach out, perhaps making some sort of request to the Steam page, parse out this IP address and sort of make a request to download, the actual malware onto the system, right? It looks like it downloaded a dynamic link library, which was used to, fetch a couple zip files from that remote IP address. We can even see some network-based indicators here. Again, the DFIR report is amazing. we get all of these different artifacts here, right? So we can see the actual requests that were made. We can see the names of the files, right? So 152.zip, 1522.zip, with the specific user agent, which sort of clued in the analyst that, hey, something is not particularly right here. So yeah, so this is the technique, right? We could go through the entire report. It's super interesting. It gets pretty in-depth and eventually, leads to the Black Suit ransomware, which is not good, but this is the indicator I want to try to recreate, right? Or dig into more because it's so accessible, right? Anyone can just make a Steam account and host whatever they want in here. And maybe if we're lucky, we can develop some very simple proof of concept, thinking nothing more than just a PowerShell one-liner to sort of grab this, whatever we want to set here, and maybe take this a step farther and actually do some command and control through Steam, right? So maybe we can actually send and receive some data to whatever IP address we want. And so that's the plan for today. I'm not sure if this is going to work. I have no idea. So we're going to try and hopefully not fail together. But if you don't want your time wasted, I will put a little message right here, a little indicator, letting you know if we did manage to make this happen or not. And so with that, let's dive right in. And so the first thing I need to do here is actually create a Steam account to host our command and control server. Can't believe I'm saying that. But, fortunately it's free. Anyone can create a Steam account as long as you have an email address, right? So that's what I'm going to do now and get our account set up. And now we just need to set up a Steam account name. And so I'm just going to set it up with like normal information to start off with because we can pretty easily change this, I'm pretty sure, once we have our account set up. So I'll just call this Not Evil Attacker. That's available, nice. We need a strong password. All right. All right, I think we're good to go here. You can see I've set up my Steam account as Not Evil Attacker. We'll be changing that shortly. And also we have the sort of real name here set to also Not Evil Attacker. And that's also what we're going to use, I think. Just the way I'm sort of mentally thinking of how this will work is maybe we can have the IP address here for our command and control server as our sort of real name and whatever commands we want to run as the sort of username here. And then we can sort of leverage both to do some interesting things. So with that, let's set up everything on the endpoint now. All right, so I have my simulated attacker machine here running Kali Linux because we're super elite level. And this is, again, going to be our sort of simulated attacker that might be sitting out on a publicly accessible endpoint hosting that command and control, right? But of course, we're just going to simulate this internally within a sort of lab, internal VNet. And so what I'm going to do is run ifconfig and grab my sort of internal IP address here for our attacker machine, which is going to be 10.0.2.5. And then I'm going to hop over to our victim machine here, which is just going to be a standard, very fresh base install of Windows 11. Okay. And this is the IP address that I want to use for our command and control server, right? So when our victim, when our Windows machine, our victim reaches out to our Steam profile, it's going to check, what is the IP address of the command and control server? Where am I going to receive commands from? And where am I going to sort of send the output back to, right? And of course, in practice, again, this is just a proof of concept, but in practice, this would obviously be an externally hosted, externally routable IP address. But we're just doing things locally, so I'm just going to set it up as this 10.0.2.5. The exact same methodology would apply. And so I'm going to head back to my Steam page now. I'm going to edit my profile. And again, we said in this case, I think for the profile name, I'll leave that up to the command that we're going to run. And then for the real name, I'm going to set that to our IP address of 10.0.2.5. All right, so I'll just save that and head back to our profile. And there we go. So now we have the IP address, which in theory, when we set up some malware or a specific, little proof of concept script to run, it's going to search for this specific string or this IP address, and then it's going to say, hey, well, let me configure myself to use that for communication, right? And so now what I'm going to do is change Not Evil Attacker here. Just as a proof of concept, the first command I want to try running here is just going to be a classic who am I, right? So that's not assuming at all. And so I save that and head back to our profile, and you can see here we have who am I as our name and the IP address as our, real name, right? Our username is who am I. And so, yeah, there we go. And so we're pretty much good to go, I think, from a proof of concept standpoint. As long as we can reach this public URL and actually extract some contents from it, we can pretty easily create something like a PowerShell script to sort of parse through this and execute any command we want without even writing files to disk, right? So sort of in memory almost, using something like IEX in PowerShell, right? Of course, this would be probably easier using something like Python, but again, our victim here is going to be a standard installation of Windows 11, and so we'll just use PowerShell, right? Very common language here. And obviously, this is not going to be a entire command and control framework here. I just want a simple way for us to be able to run commands and send the output back to us, right? And that's all we're doing here. No clickbait. That's all I said we're doing, and that's all we're going to do. All right, and so back on our victim here, I'm actually going to use this system both to sort of exploit, but also as our test bed to sort of figure out what our script needs to do, right? So what I'm going to do is open up a PowerShell prompt here. Actually, what I'll do first is just open up a command prompt and see if we can actually get some results from just curling that web page, right? And so what I'll do is head back to my browser, and our URL here is going to be steamcommunity.com/id/notevilattacker. All right, and so I'll just run curl. Let me zoom in a bit for that specific page. And it looks like we get some results, right? So very interesting. The useful thing here about the Steam URLs or the Steam profile pages, they appear to be like a static kind of web page, right? Maybe PHP based, I'm not sure. But there's no dynamic content being added. So if we have things like usernames and our sort of real name field here, we should be able to find it in this output, right? And in fact, what I can do, just clear that out. Let's run this again and pipe it over to, pipe it over to the desktop, and we'll just call it test.txt. Right, and there we go. So I'll head back to the desktop and open up this text file, which should be the output of our curl command. All right. And what I'm going to do here is search for who am I? There we go, we got some results, right? So it looks like in the actual meta content, right, the sort of head metadata content of the HTML that was returned, we have within the title there, we have Steam Community Who Am I? Let's see if there's a better way for us to find this. There we go. So we have this span tag here, the span element with the class of actual persona name, right? So our username, and we can see that's being set to who am I, right? Perfect. Yeah, so there we go. So we can use that to sort of, regex out or say, let me pull that value out of this result and set that to a variable, for example, in our script. Now let me also try doing a search for that 10.0.2.5. No, looks like we did not get that. That's unfortunate. Let's try to find out why. So I'm going to head back to that Steam page. Okay, so it looks like it's not sort of printing out the real name, I guess, for privacy reasons. I didn't see anywhere in the settings where I could specifically allow that, but we might be able to use something else here. All right, so I was scratching my head trying to figure out why that wasn't working. Why could I not see the name field? Apparently it's a limited account restriction, so you need to spend at least $5 in Steam in order for that to be lifted, which kind of sucks. But fortunately, I have a different Steam account that I think I spent $5 on, so that should be fine. But I thought that would be interesting to note, right? So if you did want to follow this through, you are going to have to fork up some cash in Steam so you can actually set some of those additional fields. Or maybe you could do it all within the username. I'm not sure what the username lengths are, but just for this purpose, I'm just going to hop over to a Steam account I already have. All right. That took an annoying amount of time for me to figure out. I think there's like some sort of syncing or caching issue on Steam's server end where it just takes some time for this to update, which kind of sucks. But apparently from what I've seen, the username itself or the command that we want to run does not take too long to update. So hopefully we'll be fine there. But obviously this is not an ideal situation. This is just to see, hey, will this work? So I think we're good to go now. I want to start making our PowerShell script, right? So what I'm going to do is open up the command prompt again. Oh yeah, let me try running this again, this time for NotEvilAttacker1, and piping that over to a text file so I can open it up and make sure we get everything that we need, right? So for example, who am I is the command we want to run. Looks like we're getting some results here that we can hopefully filter through if we need to, right? So this actual persona name field here, we can probably just grab that field right out of that. And then for the moment of truth, do we have 10.0.2.5? There we go, we do. Right under this header real name class here, right? Or this div. So perfect, that's looking good. We should be able to work with this. All right, so now what I'm gonna do is just open up a PowerShell prompt. I'm gonna try to craft a script here or at least some lines that we can put in a script to help us extract this information, save it to a variable, and then make some, make some C2 communication happen, right? So first off, I want to try to just use the request to sort of grab that page again, and then we can start parsing and cutting through it to extract the elements we need, right? And the easiest way to do that is just run Invoke-WebRequest, and for the URI, provide that path to the Steam profile page, right? And what I'm going to do is actually set this to a variable just for our testing purposes. I'm just going to call that Steam and set that to equal our Invoke-WebRequest command here, right? So run that. That should save to that variable. And now what I can do is just print out the steam.content. And now it's, pasting out all of that information that we, the same kind of thing that we saw when we crawled the web page, right? And so within this output, we should be able to find things like, who am I, right there. And eventually, if we scroll down, we should be able to find that IP address as well. And so what I'm going to try to do, just because it's right here, I'm going to try to extract this specific name from our output here, right? All right, and because I'm pretty lazy, I just asked ChatGPT to hopefully extract out that field for us, or that specific value from our output, and try to write it to its own kind of variable, right? So just for a test, I'm going to paste this in, and all it's really doing, as you can see, again, don't just run things blindly, but it's parsing out that Steam content, or the content of our sort of Steam variable here, or all of that output, and then it's going to pipe that over to select string, right? So kind of like grep, and it's looking for a specific pattern. Right, so it's looking for that span class of the actual persona name, and then we have some regex here to basically say, hey, I want to grab anything within this span tag, and then sort of print out the sort of value of that first match, right? When we do that, there we go, so it works. So the AI overlords are saving us during this project, right? So now we just have that who am I, or the actual command that we want to run, and all I need to do now is just sort of set that output to its own variable, which I'll just call command, and for some reason my terminal, or my window here is getting cut off. Let me clean that up and try again. All right, so I'll paste this in. So we're going to save that over to the command variable in this case. And there we go. So now, we have our Steam output, right? Whoops. Let me print out the Steam content, right? And then we also have this command variable as well, which is just going to read who am I, right? So this is perfect. We are halfway there, right? And now we just need to grab the command and control IP address, right? And so let's try to remember where that was, just so we can once again, use similar techniques there to extract just that IP address. So that's going to be somewhere under this div here. So it looks like we have a bunch of white space as well. So that might be something we have to deal with. But let's see what we can do. So I'm going to grab this here. All right, and if we are on a roll with ChatGPT here, this is the additional string that it gave us, or the additional pattern. Again, I often use AI for, regex patterns or, pattern matching, because it saves a lot of time, right? So as we can see, what it's doing here is it's looking for that header underscore real name ellipsis kind of element, and then it's looking for basically anything inside of basically these BDI tags that we found, which are interestingly named, and then it's basically just grabbing that out and hopefully pulling back the value, in which case it is, right? So it looks like we have our IP address now. Again, that just saved us so much time. It'd be a lot easier in something like Python, right? But in this case, just a proof of concept to run in a PowerShell script. We now have that, and we can save it over to we can just save it over to something like IP and then complete our script that way. And so let's actually write out this script now. All right, so sue me, I'm writing out this script in Notepad. But again, just a test here. What we're doing is basically everything we just ran, just sort of in a script format, right? So we're saving the Steam variable, whatever the output is of our Invoke-WebRequest. We're extracting out the command, right? The actual command that's being run. And in this case, we're getting that from the persona name field, or, the username of the Steam account. And then we're grabbing the IP address, which is going to be, again, that sort of real name attribute that we found in the Steam account as well. And then just to make sure everything's working, I'm just writing out the results here into the PowerShell window, right? So I'll just save this over to the desktop as free vbucks.ps1. All right. And then we should be able to just run that within a PowerShell context, right? All right. And I'll just head over to the desktop. And if I run a dir, we should be able to see our script here that we can just .source and run. All right, so fingers crossed this works. There we go, right? So that was pretty quick as an execution. We grab that information, and we have the command of who am I and the IP address to send the results back to, which is perfect, right? So we got what we needed here, right? We just need to now execute whatever command is in the command variable, right? And so before we do that, I'm going to head back over to my attacker machine. All right, and so what I'm going to do is just set up a simple netcat listener on port quad 4, because again, we're super elite level hackers here. And this is not to catch a reverse shell or anything, right? Maybe we'll play around with that later. This is just so we have somewhere to log the results, right? The actual, output of the commands, right? And obviously there are a ton of different ways we could do this. This is, again, just the simplest, the most minimum viable product here, just so we can get some output, right? All right, and so with that listening and running, I'm going to head back over to the victim here, where we're actually writing our script. And I'm just going to add on to basically say, hey, let me execute whatever the command is, right? That's going to be pretty much the simplest command in this script. And I'm just going to use IEX or invoke expression and just point it over to the command variable. Excellent. And that's basically just going to execute, in this case, who am I? But that's obviously not going to send us the results, right? It's just going to sort of run locally. And, if we had a PowerShell window opened up, it might give us the output, right? But we want to send that output back over to our attacker listening command and control machine, right? But what I'm actually going to do is set this over to its own variable called output. And then I'm going to go ahead and add a couple extra lines here to make this connection work, right? So you can see here what we're doing, basically setting up a TCP connection over to the IP address that we've extracted and sort of identified in its own variable, right? And then we're making that connection over port quad 4. Again, just any arbitrary port we selected. Obviously, this would make more sense to use something like 443 or 80 or like 445 or something like typical that you'd see in a network. But in this case, of course, just a proof of concept. We have to use the most elite level port here. And then we're basically just writing those streams over to the remote connection and then closing that out, right? So very simple stuff here, just a few extra lines to make that connection. So the output goes from our victim over back to our attacker listening machine, right? All right, so I'll head back to our PowerShell window, just up arrow so we can run free VBucks once again. And that would probably help if I put an equal sign after our output variable here. There we go, I think that was the issue. All right, let's try that once more, and fingers crossed. There we go, it looks like the command was run. Well, we assume it was run, we're having our little output here. But what we really need to do is head back over to our Kali Linux machines. Let me try to get back there. And it looks like we did, in fact, get those results logged. So that is one of the coolest things I've seen in a while. So that worked, right? We have we have code running on our victim through Steam. Well, not really through Steam, but you know what I mean. We're basically getting the contents of what we want to run and output back into using Steam, and we're getting those results in our Kali system here, right? So that's awesome. You can see the output of the whois command. You can see the host name here, as well as the user that we're logged into, right? So that's just awesome. And so what I'm going to do just to make sure our netcat session stays open is just set it to a while loop, which again, there's so many different ways you can do this, but obviously we wouldn't be using just like a command line based netcat to log our output here. But just, because I want to start manipulating with our commands and sort of setting them on a schedule, I'm just going to make sure this works quickly. Head back over. There we go. So it's still opened up. We should be able to run the whoami command again. Head back over, and we're getting that secondary connection, right? So I can just chill here. We're going to get any results as we continue to run things. So super cool. What I want to do now is, again, like I said, set this up in a more persistent way, right? And again, this is not going to be the most realistic thing. I just want to set this up with a scheduled task so I can run this PowerShell script, for our example, once every minute. So I can, check in to say, hey, do I have any other commands you want me to run? And if so, here's the output of those commands, right? So just so we can have more of a typical, again, not actually realistic, but more typical kind of how you would expect a command and control framework or server to run, right? All right, so I have an administrator command prompt opened up. So again, suspending disbelief here, we could just say the attacker gains sort of administrative control over the system, right? If we think about the sort of cyber kill chain or maybe MITRE attack framework, the attacker is now onto the command and control stage after sort of, taking control of this machine. They have administrator level access, and now they want to sort of implant their command and control in a more persistent way, right? All right, and you can see here what I'm basically running is the scheduled task command to create a new task to run once every minute. We're just calling it system update, right? Something super unassuming. And then for the actual task to run, it's going to be, we're calling PowerShell.exe. We're setting up that execution policy to bypass so we can load scripts. And then we're pointing it to that free vbucks.ps1 script, right? So obviously not the most stealthy here, but again, just for that proof of concept. Let's try to set that up. And in theory, if this works, you can see it was created. If this works, we should start getting those who am I command results into our sort of listening server here once every minute. Whoops. And so let me set that up again so we have a clean slate. And I'm just going to wait for something to come in, hopefully. Okay, there we go. Looks like that worked. I looked down for 1 second and we got our result, right? So now we have a persistent command and control connection, right? Obviously not super realistic here again, but it's working and that's super cool to me. So what we can do, and obviously the output here could be cleaned up a little bit, but it really doesn't matter. What we can try to do now is change that command that we want to run, right? So instead of running who am I, maybe we want to run, some other enumeration commands, or maybe we want to try to get a reverse shell on this system, right? So I don't know if we'll be able to do that with the sort of character count limit we might have with those Steam profile names, but we'll see what we can do, right? So just for proof of concept, let's try changing that to a different command, right? There we go, we got a second one. All right, just for example, I'm just going to change this from who am I over to ipconfig and see if that'll work, right? So I'll just save there. In theory, our username should be updated here, right? So I refresh, yeah, there we go. So we have ipconfig. Hopefully this works, fingers crossed. So let's return back to our Kali listener and just wait for to see how long this takes to propagate. Oh, heck yeah, there we go. That was like right away. The output could obviously be better, right? But we're seeing some awesome information here, right? We're getting the IP address of the internal system, the default gateway, right? Let's try something else here. So let's edit the profile name and let's maybe change this to system info and see if that'll work. Again, I just think this is so cool. So I want to keep trying things. All right, so let's give this another minute. We should be getting another connection any second now. I don't know if that'll be enough time to propagate, but maybe maybe it happens right away. In which case, pretty viable option. Yeah, there we go. So we're getting the entirety of the system info or the sysinfo command output here now, right? Obviously, the output, really messy, but we could obviously save this to a file. We could view it better, right? We could sort of pretty print the different columns here or whatnot. But that's pretty dang cool. Now, again, there's no way we're going to be able to fit an entire sort of like reverse shell payload into our username on Steam, right? What we might commonly do is, similar to the actual malware in the threat report we looked at, is we, tell it to download a file from a sort of staging server and then execute that, right? So what we'll try here is to just do that same technique, but instead, obviously, of just executing it immediately from the Steam profile, we'll have it reach out to execute a hosted PowerShell script that we have on our webpage, right? So what I'll do is just create just that PowerShell script that we want to run. I'll just call it temp.ps1. And then I'll paste in sort of that reverse shell syntax that we're getting from revshells.com. Right, so I'm just grabbing this straight from revshells.com, pasting in sort of my IP address and the port number that we want to connect on, and just using that payload, right? So we shouldn't need to edit anything there. I'm just going to exit that and save. All right, so now we have temp.ps1, perfect. Should be good to go. And so now what I'm going to do is just use Python 3, sudo Python 3 to host an HTTP web server on port 443. There we go. So now we have our temp.ps1 sort of listening, ready to execute. I'm going to head back over to Steam in something that might actually get me banned here. I'm going to say basically I want to run the IEX or the invoke expression command to basically run whatever is in these parentheses here, which is basically going to, again, IWR to Invoke-WebRequest, make a request out to that URL that we're sort of our web servers listening on or serving content on, which we have temp.ps1 to basically just run that PowerShell script directly in memory, right? So hopefully this works. Before we do this, well, I can just hit save. We should have some time. Head back over to Kali, set up a new terminal window here, and then netcat LNVP for port quad 5. And now we wait and hope it works, right? So let's see. Actually, I should check. No, that's too long. Maybe we can take the use basic parsing out, and that should be fine. Is that still too long? All right, so apparently that did not work because it's too long. It's still too long of a command that we need to run. So I'm trying to think of how we could do this. So what I'm going to try to do here is actually just change the name of our PowerShell script because it doesn't need to be temp. What if it's just A, right? Whoops. Yeah, so I want to change temp.ps1 and I just want to call it A, just the single character, or the single letter of A. And maybe that'll give us a few more characters to work with. I'm also going to change our web server here to listen on port 80 instead. Maybe we can just, save an extra character there instead of the HTTPS. All right, and with those changes, we've bought a little bit of time here, a few characters for us to work with. So this should be under the limit, this should be fine. We just have our A as the file name, and then instead of HTTPS, well, we're saving an extra character there. So let me try to save that. Looks like there was an error, but it still went through. Okay, good. So what I'm gonna do, all right, so quickly in a new tab here, I'm gonna set up a reverse shell listener, netcat listener on port quad 5, and just pray and hope that we get a connection back, because this would be the coolest thing if it works. So bear with me. We'll give it a minute here. We got one. We got a connection. Cool. Yeah, that worked. Who am I? Yeah, we're Elliot Alderson on the host name here. Where are we? We're on a oh, that is a messy output there. What directory? Oh, we're in system 32. That's why. Yeah, I was like, why are there all those DLLs there? Obviously, we can't clear the screen. Wow, I can't believe that worked. System info. Yeah, there we go. So the output's a mess, right? We could obviously clean that up. We could upgrade our shell if we wanted to. Even if I zoom out, it should get a little better if I run extra commands. But I can't believe that worked, right? We caught a shell through a command and control that we've set up very haphazardly over Steam, right? A public Steam profile page. So I could not be more chuffed that that actually worked. Yeah, so a little bit of suspending disbelief here and there to make everything happen, but I could see this actually happening in the wild, and in fact, it kind of did in that, again, that threat report that sort of sparked this curiosity, sparked this whole idea. So I just want to give another huge shout out to the DEFA report for, giving me that idea that I could sort of run with to see if it will work in the lab, and also for all those analysts who actually investigated that and found out all of that information, right? So super cool, right? Maybe the MITRE ATT&CK framework should add another sub-technique here under command and control specifically for Steam profile pages. So yeah, cool. Guess that's it. Because that is all it took, just this one command and this IP address to receive the output. That's all we needed to basically get control over that machine, right? I mean, technically, we had to do a little bit of finagling to get the actual reverse shell, but that's pretty normal. Right. And so I guess that's it, right? So with that, thank you, everyone. I need to go back now and change my Steam information before there's another execution, before I get banned, right? So yeah, thank you, everyone. I hope you enjoyed the video, and I will see you next time. Hopefully we're doing some more cool things. Take care.